Hey guys, it's Mr. Walker here. Welcome to another math lesson with Mr. Walker. Today's lesson is, I'm going to keep it kind of short, kind of brief, because it's kind of a simpler concept, although it does rely on a few of the skills that we've learned previously, included in what we're learning right now. It kind of jumbles them all together, applies them all together to make some estimations, to make some approximations when it comes to quotients using two-digit divisors. And even bigger than that, really. So basically, our goal for today is to use what we know about rounding and estimation to make some guesses or to make some estimations as to what an answer would be to a division problem when we have these larger numbers. Okay, so we're going to use what we know about rounding. We're going to use what we know about estimation and place value and all those kind of things to help us to look for these estimations to these division problems. So you don't need much today, just something to write on, something to write with. Once you have those things and you're ready to go ahead and click play or click continue, and let's keep rolling. Alright guys, so let's take a look at this problem here. I have 8,095 and I'm dividing that by 23. Okay, so I have these two digits here, and again, we're going to use estimation, we're going to use rounding to help us to make an approximation, to make an estimate as to what our quotient, what our answer to this problem will be. So looking at these two numbers right here, I have my dividend and my divisor. Which one of these do you think we should round first? The whole number here or our divisor? Which one do you think we should round first, and why? Okay, well, we're going to round our divisor first. We're going to round what we're dividing by. We're going to round that first, because then we know like what the unit is that we're trying to like count by, right? Or trying to see how many times it fits into that other number, okay? It helps us with our multiples, basically. So what is 23 rounded to? Let's say rounded to the nearest 10. That's where I want to round it to, make a nice round number there. What's 23 rounded to the nearest 10? All right, well, if I look at that 2, that's my tens place, so I'm going to look to the number next to it. That's a 3. That 3 is less than 5, so I'm going to round it down to 20. So my 23, I'm going to round down to 20. Now, this is going to make it a little bit easier to figure out how many times 20 goes into 8,095, because I can count by 20s, right? It's basically like counting by 2s, 2, 4, 6, 8, except that we're in the tens place, so it's 20, 40, 60, 80, so on and so forth. So that's going to make it a little bit easier now. I'm also going to round our divisor, though, the number that we're dividing by, or dividend, I should say. But I want to think about it, and the place value I want to round to, I want to make it easy to divide it by 20. So I want to think of like a nice round number that 20 might go into. So actually, if I round to the thousands place, that's going to give me the number of 8,000, right? If I round to the thousands place, rounding to the thousands place, I'm looking to the number next to it. It's going to stay at 8, so that would make a nice even round number of 8,000. And I can divide 8,000 by 20. That's pretty easy to do. All right, so I have my 8,000 divided by 20. I can think of this as a couple different ways. I could set it up a couple different ways in my head to kind of think about it. One thing is I'm going to basically cross out both of these, divide them both by 10 to make smaller place values, right? So I could do that, and then I just have 800 divided by 2. 800 divided by 2 would be 400. So basically dividing it in half. So my answer here would be 400. All right, so a lot of this was kind of like mental math in a way, kind of working it through that way. But this gives us an estimate or an approximation as to what the answer is going to be. It's not the exact answer to this, but when we get to the stage where we're finding the exact answer, we can have a ballpark already of where our answer should be. So we know our answer should be around 400. Could it be a little bit more? Sure. Could it be a little bit less? Of course. But we know it should be right around there. So if we're getting an answer that's like 7,000 and something, we know we're way off base, and we might want to check our math and see what we did. But our answer should be right around 400 somewhere, okay? All right, cool. That was a good example. Let's take a look at another one. All right, again, I have two numbers here. I have 2,691 divided by 48. And I'm going to round these numbers. I'm going to get some good estimates here, so that way I can estimate what my quotient will be, what my answer will be in the end. So I'm going to round my 48. I'm going to round it up to 50, right? 'Cause it's pretty close to the number 50. And then whatever I round my dividend, the number that I'm dividing, or the number that I'm actually dividing, whatever I round it to, I want to make sure that 50 can go into it equally or evenly or at least easily, right? Something I could picture easily. So let's see, 2,691. Well, I know 5 times 5 will give me 25, so I could go to 2,500. That's not a super close estimate, but as far as rounding is concerned, because if I were to round to the thousands place or even to the hundreds place, it would go up to 2,700, not down to 2,500. But it's okay because I'm still using a pretty close estimate. I don't necessarily have to round exactly on this to be able to get that estimate. I could also look at this and go, okay, well, 2,700. I know I could get pretty close to that with a 50 as well, so I could use that one. And I could even go up to 3,000 if I wanted to, because I know 5 times 6 is 30, so that would be a pretty easy estimate there. So I really have like 3 different estimates I could use here. All right, so I'm gonna just cross this guy out, and I'm gonna stick to my low end and my high end here, and we're gonna do 2,500 or 2,500 divided by 50 and 3,000 divided by 50, and see what kind of answers we get here. So if I do the first one here, 2,500 divided by 50, that's going to give me, well, 50. 50 times 50. I did the work over here. 50 times 50 would be 0, 0, placeholder, 0, 25. You get the idea, 2,500 there. So that's that one. So if I did 3,000 now, 3,000 divided by 50, well, that's going to give me 60. Okay, so I have 2 answers here, a 50 and a 60. I had 2 different estimates here. So what does that mean? What do you think that means as far as what our actual answer might be? Well, these are just estimates, right? And neither one of them are going to be right or wrong, okay, because they're just estimates. So no matter what path you went down, they're still considered right because they're estimates, okay? What this tells us, though, is that our answer is probably going to fall somewhere in between these 2 numbers, in between a 50 and a 60. When we find our actual answer from this problem up here, it's probably going to fall between a 50 and a 60, okay? So as long as you chose one of these paths to go down, one of these estimates to use, or an estimate close to that, you're going to be okay as far as this lesson is concerned, as far as finding an estimate or an approximation of a quotient. So you're going to be okay with that. When we find our actual answer, we'll just know that it might be a little bit more one side or the other, depending on where we fell in this one. Okay, so cool thing about this is an estimation. There's not necessarily a wrong answer as long as you're close, as long as you're using reasonable estimations, reasonable rounding to help you get your estimates. There's not really a wrong answer, so it's kind of cool. All right, here's another example where the same sort of thinking would kind of play out here. So we have 9,215 divided by 95. Now, if we were going to round this number 95, from what we've been working on in the past, the rules we've kind of been following before, if we rounded to the tens place, we would look to the number next to it. That's a 5 or greater, so we would round this up to 100, which is perfectly fine. But because we're using estimation and approximation, it's also okay if we were to leave that number at a 90, if we were to round it down to a 90. It's okay if we don't necessarily follow the rules in this case, because we're just using estimation to help us get an approximate answer. We're not being told to round to a certain place. We're not being told to use a certain place value in our number. So it's whichever one we feel is easier to use or makes more sense to us in our estimation or is more reasonable, that's the one we can use. Same thing out here. If I was going to round this, I would probably round it down to 9,000, which would make sense too, following our rules of rounding, right? But you could also round up to 9,200 if you wanted to, 9,200. That might make it easier to do as well. It would be whatever works for you guys, whatever makes the most reasonable sense. I could even round it all the way up to 9,500. 9,500. Although my estimate might be a little bit further away from what my actual answer is going to be, it could still be a reasonable explanation because it's going to make sense for what we're doing here. So why don't you guys decide what path you want to take, how you're going to divide, what estimates you're going to use, and then give me the answer in your online here, and we'll kind of see where everybody falls. All right, so hopefully you guys are getting the hang of using estimation and rounding and place value to help us to get an approximation or get an estimation for a quotient, for an answer to a division problem. Again, this isn't finding the actual answers, it's just getting us a close guess as to where the answers are going to fall. So when we find the actual answer, we know whether or not we're close to where we should be if we have the correct answer. If you guys have any questions, comments, or concerns, please reach out and let me know. I appreciate you guys watching, and we'll talk to you soon. Thanks.